All right, let's dive into one of the most famous, most debated, and honestly most mind-bending thought experiments in the entire field of AI. We're talking about John Searle's Chinese room argument, an idea that really makes you question what it even means to think.
So, let me just start by asking you this. If something looks like it understands, if it talks and acts in a way that's totally convincing, is that the same as actually understanding? Or could it just be a perfect, empty imitation? That question, right there, is the puzzle at the heart of this whole thing.
You know, for decades, the holy grail of artificial intelligence has been answering that one simple question. Can a machine really think? And to get why this is such a heated debate, we've got to look at the boldest claim that was being made by AI researchers.
This is what the philosopher John Searle famously called strong AI. And let's be clear, this isn't the idea that a computer is just a neat tool to help us study the mind. No, no. The claim is way bigger than that. It's the idea that the right kind of computer program isn't just a model of a mind, it literally is a mind. That it has real thoughts, genuine understanding, maybe even consciousness.
And you know, back in the late 1970s, programs were getting scarily good. Check this out. A program at Yale could read a little story about a guy who gets served a burnt hamburger, gets mad, and storms out of the restaurant. Then, if you ask the program, did the man eat the hamburger, it would say no. Now, the story never says that explicitly. The program had to infer it to put two and two together. And for the believers in strong AI, this looked like the real deal. It looked like understanding. But John Searle wasn't buying it. Not for a second. And to show why he was so skeptical, he came up with this absolutely brilliant thought experiment. He asks us to forget about the computer for a minute and instead step inside what he calls the Chinese room. Okay, so picture this. You are locked in a room, all by yourself. And let's say you're a native English speaker, but you don't know a single word of Chinese, written or spoken. To you, Chinese characters are just intricate, meaningless shapes. Just a bunch of squiggles, as Searle put it. Now here's the setup. People outside slide batches of these Chinese symbols under the door. First one batch, then another. Now inside the room with you is a giant rulebook, but it's all in English. And here's the key. The book doesn't translate anything. It just gives instructions like, whenever you see this squiggle followed by that squiggle, go find this other squiggle and write it down. You're just matching symbols based on their shape. You follow the rules and you pass your new set of symbols back out of the room. And here is the kicker. You have no idea what's going on, but the people outside are calling that first batch of symbols a story, the second batch questions, and the symbols you're handing back out, they're calling those answers. And because that rulebook is so incredibly detailed, your answers are perfect. They are absolutely indistinguishable from the answers a native Chinese speaker would give. So from the outside, the system, you, and the room, has passed the test with flying colors. It seems intelligent, it's acing the conversation. But, and this is the million-dollar question, do you, the person in the middle of it all, understand a single word of Chinese?
Of course not. The answer is a big fat zero, not one word. You've just been manipulating squiggles you don't understand. And this is Searle's big point. If you don't understand Chinese in that room, then the computer program you are basically acting out doesn't understand Chinese either. You have all the parts, the program, the input, the output, but there is zero actual understanding.
Okay, you might think that's checkmate, right? Well, not so fast. The supporters of strong AI were not about to give up that easily. They came back with a few counter-arguments, and the first big one is called the system's reply. The argument goes something like this. Okay, fine. The person in the room doesn't understand, but you're focusing on the wrong part. The person is just the CPU, just one component. It's the entire system. The person, the room, the rulebook, the scraps of paper, the whole shebang, that's what understands Chinese. Searle's comeback to this is, I think, just brilliant. He says, all right, you want to talk about the system? Let's do it. Let's get rid of the room. Imagine the person memorizes the entire rulebook. They do all the calculations in their head. Now that person is the entire system. There are no external parts. But do they now magically understand Chinese? Of course not. All they've done is internalize a process. They still don't comprehend. So, with the system's reply on the ropes, the strong AI defenders tried a different tactic. Maybe the problem, they thought, isn't the program itself, but the fact that it's totally disconnected from the real world. This leads us to the robot reply. The idea here is, let's give the system a body. Let's put that Chinese-speaking program inside a robot. Give it a camera so it can see, and arms and legs so it can move around and interact with things. Now the symbols aren't just abstract squiggles anymore, they can be linked to real objects in the world. Surely that has to be real understanding, right? And you can probably guess Searle's response. Nope, still not it. For him, just adding a camera and some wheels doesn't magically spark comprehension. It completely misses the point.
He just runs the thought experiment again. Imagine you're still in that little room following your rulebook. Only now the room is inside the robot's head. The symbols coming in are signals from the robot's camera, and the symbols you pass out make the robot's arms and legs move. You're still just in there, shuffling meaningless symbols. You have no idea that this squiggle means that's a chair, or that one means pick up the glass. The understanding still isn't there.
So after all of this back and forth, what is Searle's actual point? What's the fundamental principle here? Well, it all boils down to a crucial distinction between two pretty important words: syntax and semantics. Okay, so syntax is basically the rules of grammar. It's about how you arrange symbols without any concern for what they mean. It's all form, no content. Computers are masters of syntax, and that's what you were doing in the Chinese room. But semantics, that's the good stuff. That's meaning. It's knowing that the symbol hamburger actually refers to that juicy, delicious thing in the world. And Searle's knockout punch is this: you can't get semantics just from syntax. In his own words, as long as a computer program is just shuffling symbols based on formal rules, those rules alone are never, ever going to add up to genuine understanding. It's like trying to build a brick wall out of water. You're just using the wrong kind of stuff for the job. So what is this special sauce that our minds have but computer programs lack? Well, philosophers have a fancy word for it: intentionality. But don't worry, it's a simple idea. It's just the aboutness of our thoughts. When you have a belief about the weather, your thought is about the weather. When you want a hamburger, your desire is about a hamburger. Our thoughts point out into the world. And for Searle, this aboutness, this intentionality, doesn't come from a program. It comes from biology. It's something that our squishy, wet, biological brains just do. He uses this killer analogy. You can run a perfect computer simulation of a hurricane, right down to the last drop of rain. But is it going to get you wet? Of course not. You can simulate digestion, but it won't digest your lunch. So why, he asks, should we believe that a simulation of a mind is the one exception where the simulation suddenly becomes the real thing?
Now, it's really important to get this right. Searle isn't saying a machine can't think. In fact, he'd say your brain is a biological machine, and it thinks just fine. His argument is that thinking can't be just about running a formal program. It's not just software. And that, of course, leaves us with the big, provocative question that philosophers and scientists are still wrestling with today. If a mind is more than just the program running on the brain, then what on earth is